Okay, so let's start the session. Hello everyone, a very good evening to all of you. Yes, my name is Pooja Verma, I'm PMRF Research Scholar from IIT Kharagpur and course instructor for this course is Dr. M.K. Bhuvan, Department of Electronics and Electrical Engineering, IIT Guwahati. This is a week 4 live and interactive session on computer vision and image processing fundamentals and application. Okay, so this is a live and interactive session, so please try to interact. You can use chat box for asking and interacting. Otherwise, you can unmute yourself and ask your doubts. Okay. And one more thing, I hope I'm audible and visible. Any one of you can confirm it? Okay. So I hope all of you have gone through this week video lectures, right? So this is a full week 4. So basic image processing concept you must have been gone through this one. So we will solve some numerical problems as well as conceptual problems based on this week video lectures. And these are some textbook and references which you can follow. So for this is our first question for this week. Question is calculate the energy of the discrete signal x, that is 1 minus 2 3 0, using Parsevals theorem. So would you like to answer this question? First you try, then I will solve it here. So anyone of you can just let me know what is a Parsevals theorem? Can you calculate the energy of the discrete time signal using Parsevals theorem? Okay, so as already you know that the energy of the sum of squared magnitude of the sample. This one is a Parsevals theorem. So using Parsevals theorem, the energy can be calculated using the sum of the square magnitude of the samples. The Parsevals theorem is represented by this equation. E is equal to summation of mod of x of n whole square, where this n will vary to n 0 to n minus 1, where n is the number of samples. So here how many samples are there? 4, right? 1, 2, 3, 4, right? So that will vary from n is equal to 0 to n, that is 3 mod of x of n square, right? So if you just open and put the values of this, so here you will get mod of x of 0 whole square, then x of 1 whole square plus mod of x of 2 whole square plus mod of x of 3 whole square. So this is corresponding to 0 value, 1, 2 and 3. So just put these values in this one. So mod of 1 square plus minus of 2 mod of minus 2 square plus 3 square plus 0 square, right? Now if you find that, so 1 square is 1 only, minus 2 square is 4, right? And 3 square is 9, and this one is plus 0. So if you just add all these values, you will get 14, right? So 14 corresponds to which option? That is C, right? So option C is the correct answer for this question. Is it fine? So these are the basic questions. I hope all of you are fine with this question. Can we move our next question? Okay, so moving to our next question now. Now next question is, given a 2D image function that is f x y is equal to del of x minus x naught and y minus y naught, what is its Fourier transform f of uv? So here function is given. Now we need to find out the Fourier transform of the 2D image function. So which option can be a correct one? Any one of you? Please at least try. Which option can be a correct one? Okay, so any one of you can just tell me what will be the Fourier transform formula? You can just tell either 1D signal or 2D signal, anyone. That must be all of you know that, right? Nobody is interested for answering. Okay, so let's see. So the Fourier transform of the 2D continuous time signal is that can be represented by f of uv. This is the frequency domain signal. This is the frequency domain representation of the fxy minus infinity to infinity f of x comma y e to the power minus j 2 pi ux plus uy dx dy. This is for Fourier transform 2D image function, right? So here fxy is given this function. So if you put it in this function, so you will get minus infinity to infinity. Here again, just put del x minus x naught. So this one will be the comma. Okay, so please continue. Okay, so and y minus y naught e to the power minus j 2 pi ux plus uy dx and dy, right? So now if we use the shifting property of the direct delta function, that is an impulse function, that so use shifting property, or we can say that using our direct delta function, which states that minus infinity to infinity del of t minus t naught dt is equal to x of t naught, right? This is a shifting property of the direct delta function. Now, if we apply this to both in x and y direction, apply this property both x and y directions, then we can find out in this one e to the power minus j 2 pi u of x naught plus v of y naught, right? If you just apply this property here, x of t naught is it is there. So what is our function? That it is e to the, so in the place of x naught, here will be the x naught. In the place of y naught. If you apply this property to in this one, okay, so you will get this function. So which option is the correct one? Option B, right? E to the power minus j 2 pi u of x naught plus v of y naught. Is it fine? All of you? Any doubt, any problem? Can we move our next question? Is it fine? Okay. Now moving to our next question. Perform a label 1 hard wavelet decomposition on the sequence x is equal to 8462 and the approximation average coefficients are, they are asking only for average coefficient. So we need to perform label 1 Haar wavelet decomposition for the given sequence. So any one of you? So what we are doing in the Haar transform? So just we decompose the given sequence and divide it into a, first we will divide this sequence into to the adjacent, yeah, pairs. So average of the first two and last two to get the average or approximation coefficient. Okay. So what will be the answer? Anyone can just tell what will be the answer for this question? Okay, yeah, okay, yeah, right. Okay, so let's solve this problem. So already someone has told me to perform a label 1 higher wavelet decomposition for the given input sequence. First, we need to divide this input sequence into the adjacent pairs. So what will be our first pair? First pair is 8 and 4, right? And our second pair is 6 and 2, right? Now, to find the approximation or average coefficient, that is calculated by the average, let's say average is calculated, already we know that x of 2n minus 1 plus x of 2n divided by total number of, so here 2, so divided by 2. So if we find the first one, so 8 plus 4 divided by 2, so 12 by 2, that is 6. And similarly we can calculate for the second pair, so I'm just writing a2, so 6 plus 2 divided by 2, 8 by 2, this one is 4 we will get. So the resulting approximate vector is, or we can say that average coefficients are 6 and 4, right? So this one is that is option A is the correct answer for this question. Okay. Okay. It's A. So now you have understand why it is A is correct. So that's just we need to take the average of the given pairs. Now moving to our next question. So now the next question is related to the same question still. Now they are asking using the same sequence that is x8462, what are the label 1 detail or difference coefficients? So as in the previous one we have calculated the approximation or average coefficient. Now we need to calculate the difference coefficient. So basically what we are doing here, we are taking the difference between the adjacent pair. So here two pairs already we know that we have got. So just we need to take the difference. Okay. Yeah, that is correct. So first we divide the sequence into two adjacent pairs. So first pair already we know that 8, 4, and our second pair is 6, 2. Now to find the detail or difference coefficient, I can write it. The difference coefficient. So just I need to take a difference. So first D1 is 8 minus 4 divided by 2, that is 4 by 2 is 2, and D2 is 6 minus 2 divided by 2, that is 4 by 2, it is also 2. So the label 1 detail coefficients are the label 1 detail coefficients are 2 and 2. So yeah, option A is the correct answer for this question. Okay, okay, I hope all of you have got this question and most of you given answers as well. Okay, great. Okay, now moving to our next question now. Now next question is which of the following 2 cross 2 matrices represent a normalized Hart transform matrix? So either option A, B, C or D. So which of the following 2 cross 2 matrices represent a normalized Hart transform matrix? Would you like to answer this question? Any one of you? So let's see the solution here. So the Hart transform that is based on the Hart functions. So for n is equal to 2, the unnormalized Hart matrix is composed of a row representing the trend that is averaging and row representing the fluctuation that is a difference. So the Hart transform for n is equal to 2 is represented by this matrix. So a matrix that is considered as a normalized of its row if its rows are orthonormal. So this means the magnitude of the each row vector must be 1. So first we need to calculate the norm of the first row. So norm we can calculate root of 1 square plus 1 square. So that is 2. Root of 2. So to normalize this matrix, so this every element must be divided by this norm. So the normalized 2 cross 2 matrix is represented by this one by root 2 mat in matrices 1 1 1 and minus 1 that corresponds to a option B. Okay, so basically the Haar transform that is already based on the Haar function, we know that for n is equal to 2, the unnormalized Haar matrix is represented by this one, this function. And if we normalize, so first we need to take the norm of the first rows. So here we are taking the norm of the first row that is coming root of 2, and if we divide, if we want to normalize the overall matrix, we need to divide this one to a normalized value, so that we will get. Okay, so this is corresponding to option B. This is a 2 cross 2 matrix representation of the normalized Haar transform. Okay, this is the Haar transform matrix, normalized Haar transform matrix. Option B is the correct answer for this question. Okay, so is it fine? Okay, so now moving to our next question. So now next question is, if the covariance matrix of a vector variable x is given as 4009, what are the eigenvalues? So can you calculate the eigenvalues if the covariance matrix is given? Can you just let me answer for this question? At least try. Okay, B. Okay, the eigenvalues of this matrix. So already you know the characteristic equation. So it is already we know that it is a diagonal matrix, right? Okay, yeah, C, correct. But okay, so let's check. So already we know that this is a diagonal matrix, right? So the eigenvalues are for the diagonal matrix simply the entries that is located on the main diagonal. And we can also calculate using the characteristic equation to find the eigenvalues. Characteristic equation. So you know that that is a determinant of that is covariance matrix minus lambda I is equal to 0, right? If you just calculate the determinant like 4009 minus, I can write lambda 1001, that is equal to 0. So if you just calculate it, so here we will get 4009 and here we will get lambda 00 lambda is equal to 0, and it is obviously here it is there determinant. So here matrix you will get 4 minus lambda 0 9 minus lambda. Okay, so now can you calculate it, the determinant? So if you just 4 minus lambda into 9 minus lambda, this diagonal minus 0 is equal to 0, right? This one is a determinant of the 2 cross 2 matrix. So if you just simple find out 4 minus lambda, 9 minus lambda is equal to 0. So lambda, what will be the values of the lambda? 4 and 9, right? Or you can say that lambda 1 is equal to 4, lambda 2 is equal to 9, right? So these are the eigenvalues of the given matrix. So this is a option C is the correct answer for this question. Okay. So if any matrix is given and it is given to find out the eigenvalues, so you have to use the eigen characteristic equation. Okay. So I hope you have get it. So now moving to our next question. So now next question is also related to the previous question. For the covariance matrix given in the question number 6. So is it audible for others? Is it fine now? Okay. So if it is not audible or visible, just let me know. Okay. So our next question is for the covariance matrix in question 6, which vector represents the principal component, that is direction of the maximum variance? Which component is represents the principal component? Already we have seen what is our covariance matrix in the previous question, like 4009. This is our covariance matrix. That is 4009, right? So which vector represents the principal component direction of the maximum variance? The principal components corresponding to the eigenvector with the largest eigenvalue. So already we find out the eigenvalues, like lambda we have got 4, lambda 2 that is 9, right? So here the largest eigenvalue is this one, 9. So we can say lambda maximum, we can say that the largest eigenvalues. So the corresponding eigenvector for the diagonal entry, that is for 9, here it is related to x position. This is the x, this one is the y, right? This column represents the x in the direction x, this one related to y, right? So is the unit vector along the this one. This corresponding eigenvector, I can write it. The corresponding eigenvector for the diagonal entry, that is 9 in the y position, or you can say that in the y direction. So the unit vector along the y axis will be the y axis is 0 1, right? 0 1 transpose. If it is in the x position, so 1 0 will be there, 1 0 transpose. If it is in x position, like if 4 is the highest eigenvector, so it is in the position x, right? So this the eigenvector is represented by 1 0, but here it is related to position y. So the unit vector along the y-axis is represented by 0 1 transpose. Okay, so option B is the correct answer for this question. Is it fine? Have you understand this question? Is it okay? Okay, so now moving to our next question. Now next question is the 4-point DFT of the sequence x of n 1 1 1 1 is. What is the 4-point DFT of the given sequence? So anyone have any idea how to calculate the 4-point DFT? What is the formula? Anything?
అంతే అది వేస్ట్ లేదు తోలు
Ah, yes. DFT formula, simple. Yeah, Gayatri, you are saying something. Okay, so let's see. I will let you know what is the formula for the DFT, endpoint DFT. Then we can derive from the given sequence the 4-point DFT. Okay, so the formula for the endpoint
పైకి
DFT
దూకోవా
for a sequence x of n is that is represented by x of k, where n will vary n to n minus 1. Just a minute. X of n e to the power minus j 2 pi by n k. Okay, this is the formula to calculate endpoint DFT for a given sequence x of n. Okay, so here n is equal to 4, capital N is equal to 4, right? Here 4 points are given 1, 2, 3, 4. Okay, so now we need to calculate DFT for each sequence. This is a position 0, this is a position 1, this is a position 2, and this is the value at position 3. Okay, so first we will calculate at k is equal to 0. So here x of 0 will be there, right? Now here n again vary n to 0 to n minus 1, 4 minus 1 is 3, right? X of n e to the power minus j 2 pi by 4, here n, and here we are calculating for k equal to 0. So here 0, right? So this will make the whole function e to the power minus j 0, and e to the power 0 is 1, right? Now n will vary 0 to 3, x of n e to the power minus j 0, and that will be 1. So we can write x of n only summation n will 0 to 3. So now if we put the value n to 3, x of 0 plus x of 1 plus x of 2 plus x of 3. Simple addition of all the x of n values. So just all are 1, right? Plus 1. So this is equal to 4. So x of 0 that we have got is 4. Okay, now similarly we need to calculate for x is equal to 1, 2, 3 at 4 values, right? So here we can write it here x of 0 that we have 4. Now I am just removing from here so that we can calculate for the other k values. So now we will calculate at k is equal to 1. So here the value x of 1 will be there, right? So here n again, n is equal to 0 to 3 x of n e to the power minus 6 2 pi by 4 n into 1, right? So now if you just calculate n is equal to 0 to 3 x of n e to the power minus j here to the pi by 2 n. Now put the values of n, okay? So x of 0 e to the power 0 again, x of 1 e to the power minus j pi by 2. If we are putting 1 here, then x of 2 you will get e to the power minus j pi, because this 2 will be cancelled out. Now if for x 3 you will get minus j here 3 pi by 2, right? Now just calculate e to the power minus j pi by 2, e to the power minus j pi, and e to the power minus j 3 pi by 2 values. Right. So if you calculate, so 1 into 1 here, this value x of 1 is again 1. Now if you calculate it, so e to the power minus j pi by 2 you will get minus j, x of 2 is here, and e to the power minus j pi value you will, if you calculate, you will get minus 1 plus 1, and this value you will get j only, e to the power minus j 3 pi by 2. Okay. Now if you just 1 minus j minus 1 plus j, so that all will be cancelled out, equal to 0 you will get. Okay. So now x of 1 we have got 0. Now similarly we need to calculate for x is equal to 2. Here I'm just removing it from here. So yeah, k is equal to 2. So e to the power 2 pi by 4 n into 2, right? So here 2 and all these values will be cancelled out. So you will get n is equal to 0 to 3 x of n e to the power minus j pi n only. Now put the values of n. So x of 0 e to the power 0, x of 1 e to the power minus j pi plus x of 2 e to the power minus j 2 pi plus x of 3 e to the power minus j 3 pi. Okay. Now calculate these values. Then you will again get e to the power 0 is 1 is 1, e to the power minus j pi you will get minus 1 plus 1, e to the power minus j 2 pi you will get 1 only, and 1, and it is also minus 1. So here all values again will be the cancelled out, you will get 0. Okay. So x of 2 is also 0. Now again we need to calculate for 3. K is equal to 3. So here 3. Okay. So can I remove this one? No. Yeah. So now put all these values and just calculate for n is equal to 3. So here you will get 3 pi by 2n. So just remove the pi and put the values of x of 0 e to the power 0 plus x of 1 e to the power minus j 3 pi by 2 plus x of 2 e to the power minus say it is for 2, so 3 pi only, x of 3. So here you will get e to the power minus j 9 pi by 2, right? Yeah, 2 is 9. Yeah, correct. So now again you will calculate, you will get 1 1 plus 1 into here you will get the plus j and here plus 1. This value is minus 1 again, and here 1 into minus j you will get. So all the functions will be the cancelled out here again. So you will get 0. Okay. So x of k, that is the DFT of a sequence, you will get 4, 0, 0 and 0. Okay. So from here option A is the correct answer for this question. So this is a procedure to calculate a DFT. So this is a formula for calculating the DFT. Just put the values for each k and calculate. Okay. Is it fine? I hope all of you have understand this question. Now moving to our next question. So our next question is, now if you are analyzing a speech signal that is sampled at fs is equal to 16 kilohertz, and here you use a short time Fourier transform, that is STFT, with a window size n is equal to 512 samples. Now we need to calculate the time resolution, that is delta t, and frequency resolution, that is delta f, of this analysis, assuming the window of a rectangular for a simplicity where delta t is the window duration and delta f is the beam spacing. Now we need to calculate the time resolution and a frequency resolution. The sampled signal and the window size is given. Okay. So how we can calculate it? So here the sampled signal fs is given 16 kilohertz and window size is 512. So already we know that the time resolution is defined by the duration of the window size, right? So the time resolution, that is delta t, is defined by the duration of the window size. Okay. So it is represented by n by fs. This is a formula for this one. So already n and f is given by 12 samples divided by 16 kilohertz. So 16 kilohertz, so 16,000 hertz, right? Or we can also hertz different samples per second. Already we know that per second, right? So sample, now first if you just divide it, you will get 0.032 second, because the sample will cancel out and second will be there, 0.032 second. Or we can also say that 32 millisecond, right? Now similarly we can calculate the frequency resolution, that is delta f, and this is basically the spacing between the frequency beams, that is the width of the main lobe of the window spectrum, and it is represented by the opposite of the time resolution, like fs divided by n. Okay. So now just opposite. So 16,000 divided by 512. So here you will get, it is in hertz. So frequency is represented in the hertz. So 31.25. Okay. So 31.25 hertz. Okay. This is the frequency resolution, and del t, the time resolution, 32 milliseconds. If you see that, option E is the correct answer. If you want to cross verify this answer, so you can do that if del f and del t is equal to 1. If this will satisfy, then the uncertainty limit of the rectangular window. So if you multiply these two, that is 32 millisecond and 31.25, you will get 1. So just multiply 0.032 and 31.25. So you will get 1. So just you can multiply and check it. Okay, if you are getting 1, then it will satisfy, otherwise not. Okay, is it fine? Have you understand this question? Okay, so now moving to our next question. This is the wrong one slide. So now next question is, a continuous signal ft, that is cos 2 pi 10 t, is sampled. What is the value of the Fourier transform magnitude at frequency 10 Hz? Anyone would like to solve this question? The continuous time signal that is given, that is sampled signal, and they are asking what is the value of the Fourier transform magnitude at frequency 10 Hz. Any one of you would like to answer this question? Okay, one. Others, please try to answer. What will be the Fourier transform magnitude for the given signal? Okay, so let's see. The solution is here. So yeah, so the given signal is pure cosine signal, that is ft cos 2 pi f naught t, where f naught t is given as a 10 hertz. Okay, in the question. So as we know that the Fourier transform of the continuous cosine signal is defined by the this property, that is cos 2 pi f naught t is 1 by 2 del f minus f naught and del f plus f naught, where this one is in this side frequency f naught and this one is this side. Okay, and already we know that del f is the direct delta function, or you can say the impulse function, right? So to find the magnitude at 10 hertz, first we evaluate mod of f, that is it is in the frequency domain at f is equal to 10 hertz frequency. So just put in this formula, so you will get mod of 1 by 2 del 10 minus at 10 and 10 plus 10. So here you will get 1 by 2 del of 0 plus 1 by 2 del of 20 if you add and subtract it. Okay, so as we know that the direct delta function, that is del of 0, is mathematically defined as having an infinite value. You know that in the del function, del of t, is defined at 0 only, right? At 0, it is the maximum, right? So at del is equal to 0 value, it is infinite value at its center, and the magnitude of the fundamental frequency f naught at that point of 0 is infinite also. Okay, so when we sample a signal with this function, del function, and its Fourier transform, that becomes periodic summation of the original spectrum. So this is defined by this one, f of s of f 1 by 2s k will vary s infinite to infinite f of f K minus Fs. So regardless of the sampling rate, so let's assume that no aliasing or accounting for the primary component. So the spectrum still consists of impulse or direct delta function at that frequency. Okay. So their magnitude remains infinite at that point at zero. It is always infinite at zero. Okay. If you multiply it with any value, that will be the infinite. So the correct option is infinite. Okay, infinite at the f is equal to 0. If any frequency is given, the value will be the infinite only. Okay, so the correct option is B, infinite for the direct delta function. Is it fine? Have you understand this question? Is it fine? Can we move to next question? Is it okay to all of you? Any problem? Okay, so moving to our next question now. So now next question is compute the DC component, that is u at u is equal to 0 and v is equal to 0 of the 2D DFT of a 2 cross 2 image. So here 2 cross 2 image matrix is given. Now we need to calculate the DC component at value 0 0 using the 2D DFT. So anyone of you know that what is the formula for the 2D DFT? Anyone? Then we will solve it here. Just we need to calculate at values u is equal to 0 and v is equal to 0. That is a frequency domain representation of the given image matrix. Currently it is in time domain. Now we need to convert it into the frequency domain. Okay, so here the formula for the 2D DFT, the 2D DFT for an M cross N image matrix, you can say image f of x y is defined by, here it is a frequency domain representation, u and v, here x will vary 0 to m minus 1 and y will vary from 0 to n minus 1 f of xy. This is a function, or you can say I. In simple, it is can write also I x comma y because it is x and y direction. E to the power minus j 2 pi ux divided by n plus vy divided by n. So this is a formula for the m cross n image function. Okay. So now we need to calculate the DC component. To compute the DC component, already we know that at u is equal to 0 and v is equal to 0, it's a calculator. So f is equal to 0, 0. Here x will vary 0 to m minus 1. The 2 cross 2 matrix, m cross n is 2 cross 2 matrix. That means m is equal to 2, n is equal to 2, right? So here m minus 1 will be the 2 minus 1, so 1. Similarly, here also y is equal to 0 to 1. I x y or f x y, whatever you can take. Here I is given, so I you can take. Okay. e to the power minus j2 pi. Here u is 0, so 0 into x divided by m is 2 plus 0 into y divided by 2, right? So here 0, 0, so that function will be the 0 only, right? So here x is equal to 0 to 1, y is equal to 0 to 1, I x comma y e to the power 0. Here this function will become 1 only. Okay, so what left? X is equal to 0 to 1, y is equal to 0 to 1, I x comma y. Now put the values. So here first we will put for y, then x. So x is equal to 0 to 1. First we will take 1 by 1. There are two summations. So first we take 1, then we take next one. Right? So I x comma 0 plus I, and it is in bracket, x comma 1. Right? So y for 0 and 1. So first we will take 0, then 1. Now just open the another summation. So you will get I. First we will take the 0, then 1. So I is equal to 0, 0 plus I 0, 1. Now we will take 1 and put in this summation. So I 1, 0 plus I 1, 1. What is? So this is the I 0, 0, like 0, 0, 0, 1, 1, 0, 1, 1, the values, right? So just it is a simple addition of all the matrix component. So 2 plus 1 plus 3 plus 4. So overall if you add you will get 10. Okay, 10. So it is related to option C. So option C is the correct answer for this question. Okay, is it fine to all of you? Any doubt, any problem? Any doubt, any problem? Okay, so can we move to our next question? Okay, I hope all of you have understand this question. So now moving to our next question. Yeah, next question is if a Gaussian function f of x is equal to e to the power minus pi by pi x square is stretched in time to f of x by 2, its Fourier transform will be. So a Gaussian function is given e to the power minus pi x square is stretched in the time to f of x by 2, then its Fourier transform will be. Option A, stretch in frequency by factor of 2, shrink in frequency by a factor of 2, or shift in frequency by 2, or option D is remains unchanged. So anyone who would like to answer this question? At least try for this question. Then we will see the detailed solution. Okay, stretching in time, shrinking in frequency, right? That is correct. Stretching in time domain, then it will shrink in the frequency domain. Yeah, that is correct. Okay, so here we will see the detailed solution for this one. Okay, so yeah, that is correct. Stretching in the time domain, it will shrink in the frequency domain. Okay, so as we know that the scaling property for the Fourier transform, so if any signal is given f of ax, that is in time domain, the frequency domain signal of the corresponding signal is f of s by a. This is a Fourier transform property. This is a scaling property of the Fourier transform. Of Fourier transform. Okay, you must be studied in your other course. Okay, so the function for here it is given f of x by 2. The function is f of x by 2. Here that means here a is equal to 1 by 2. Okay, so if you just put in this one, it is also represented by f of s in the frequency domain. Okay, so this is a Fourier transform, and in the frequency domain it is represented by f of s. Okay, so if you just put 1 by 2 in the place of a, so you will get f of s 1 by 2 here again. So you will get finally f 2f into 2s, right? You will get this one. So the term f of 2s, this one, indicates that the frequency variable s is being multiplied by a 2. Here this function is multiplied by, that means this is a frequency variable, and this frequency variable is multiplied by a factor 2, right? So multiplying the argument by a factor that is greater than 1, that results compression or shrinking of the graph towards its origin. Okay, so for the Fourier transform of for the Fourier transform, I'm writing it here shortcut for ft of the function. Here a function f of x is given e to the power minus pi x square. Okay, and then the frequency domain representation of f of x will be e to the power minus pi f of s square will be there, right? So if stretch in this part x is x by 2 in the time domain here, so the for the stretch function I can say that function f of x by 2, first we will apply it in the time domain. So here we f of x by 2, then we will get also in the time pi by x by 2 whole square, right? Now if you just compare with the frequency domain, or putting in the frequency domain, what you will get e to the power minus pi s square, right? But now if you just simply stretch this one in the frequency domain, so you will get here 2s, so you will get 4s square. Similarly, so if it will stretch e to the power minus pi s square to e to the power minus 4 pi s square, right? So the spread in the frequency domain has increased by a factor 2, or it will shrink in the in frequency domain. Then the frequency domain has decreased, so the function of the shrunk by a factor 2. So the correct option is a shrink in the frequency by a factor 2. Okay, so option B is the correct answer. So by factor 2 it will shrink. By factor 2 it will shrink. Okay, because here we are getting minus of 4 in the place of 2. Okay, here. So shrink in the frequency domain by a factor 2. Is it fine, all of you? Have you understand this question? Is it fine? Anyone have any problem? So can we move to our next question? Okay. So now moving to our next question. Now next question is, for a Haar wavelet, if phi t is a scaling function, what is the value of minus infinity to infinity phi of t dt? So a Haar wavelet function, that is where phi t is given as a scaling function, then what will be the value of integral minus infinity to infinity phi of t dt? Anyone? Any idea? Okay, so let's see the solution here. So the Haar scaling factor, that is a phi t, that is referred as a Father wavelet and is defined by the as a unit step pulse over the interval 0 and 1, and that phi t function is represented by this that is phi t is equal to 1 in the value t, between t varies from 0 to 1 and for 0 other values. Okay, now to find the total area under the curve, we integrate the function over the entire real line. Okay, since the function is a 0 everywhere outside the interval 0 and 1, that bounds the integration reduced to, that is minus infinity to infinity phi of t dt, to 0 to 1, and the value between the 0 to 1 is 1, so 1 dt. If we just evaluate the integral, so you will get t will 0 to 1, so here you will get 1 minus 0 to, that is equal to 1. So the value of the integral is 1 only. Okay, so option B is the correct answer for this question. Okay, is it fine? So have you understand this question? Okay, sure. So yeah, this is explanation. So Haar scaling factor function, that is a phi t is given, and it is also referred as a Father wavelet. So and it is defined over the unit step pulse in the interval 0 and 1. So mathematically phi of t can represent in by this function, that is if value is between t is 0 to 1, then the value will be 1, and all other values it will be 0. So to find the overall area under the given curve, that is already given in the question, minus infinity to infinity phi t dt. So you will get, so between 0 to 1, the t value is 1 and all other values it is 0. So we are taking 0 to 1, value is 1 dt. If you just integrate it, you will get the 1 only. Is it fine now, Ninad? Okay. Okay, so now moving to our next question. Now next question is, consider two vectors, v1 is 2 and 2 and v2 is 3 and 3. What is their covariance if the mean is subtracted? Assume they are the only data points. So either it is a positive, negative, 0 or undefined. What will be the value of the their covariance if the mean is subtracted. Anyone have any idea how to solve this question? First, we need to find out the mean of these vectors, and then it will subtract from the data points to find the covariance matrix, and then we need to see whether it is a positive value or negative value. So here they are asking only for the covariance. Okay, so let's first we will calculate the mean of these two vectors. So mean of the given vector. So you know that 1 by 2, that is v1 plus v2, and here v1 and v2 are the vectors, right? So if we want to add these vectors, I can write so 2 and 2 here plus 3 and 3, these two vectors. Now if you just add these two, 1 by 2, that is 5 and 5, right? So now further, if you just divide it 2.5 and 2.5, these are the mean of the given vector matrix. This is a mean vector we have derived. Okay, now to find the covariance between these two vectors, that is calculated by mean one. So to find covariance between the x and y, we can find n minus 1. This is a formula where I will vary from 1 to n xi minus mu I, or you can say mu x, yi minus mu y. So this is, we can represent mu x and mu y. This is corresponding to mu x, and this the next one is corresponding to mu y. Okay, so just put the values here. Two vectors are there, so n is equal to 2 only, right? So 2 minus 1 will be 1 only, and here also, so or you can say 0 to 1, right? So just if you just open the summation and put the all these values, so it's just simple. It is a multiplication and addition of these values. Okay, so xi, that means first one, first value xi, when it is 0, 2 minus 2.5, right? And similarly at the second, where I is equal to 1, so here again it is a 2, so 2 minus 2.5, right? Then, or you can add plus the next vector values for the mu y, it is a 3 minus 2.5 and into 3 minus 2.5 if you just open the summation. Okay, so here you will get minus 0.5 into minus 0.5 plus 0.5 into 0.5. Okay, so here you will get 0.25, and here also 0.25. If you just further add, you will get 0.5. So since 0.5 is positive number, 0.5 is greater than 0, then, and it is a positive number, so the result is positive. Positive here. So option A is the correct answer for this question. Is it fine? Have you understand this question? Any doubt, any problem? Can we move to our next question? Okay, so now moving to our next question. Our next question is, a 2D separability property states that the 2D DFT can be computed by? Option A is 1D DFT on rows and then 1D DFT on columns. Option B, summing 1D DFTs of rows and columns. And option C is multiplying 1D DFTs of a diagonal element. Or option D is squaring the 1D DFT of rows. Which option is the correct one? A 2D separability property states that the 2D DFT can be computed by. Which option can be a correct one? Any idea? Please try to answer. Okay, nobody interested to giving answer. Okay, so let's see the solution here. So the separability property of the 2D discrete Fourier transform allows a complex two-dimensional operation that is broken down into simpler one-dimensional steps. So mathematically, the 2D DFT kernels can be factored into two independent 1D kernels, one for each dimensions, or x or y dimension. You can say that x and y positions or rows and columns. So this means first we need to calculate the 1D DFT for every rows of the image or you can say matrix, and then take that intermediate results and calculate 1D DFT for every column to arrive at the final transform. So the correct option for this one is 1D DFT on rows, then 1D DFT on columns. Okay, so option A is the correct answer. So a 2D separability property that states that the 2D DFT can be computed by the 1D DFT on rows and 1D DFT on columns. Okay, is it fine? How to calculate using the separability problem property? Okay, so I hope all of you are getting. So moving to our next question now. Now next question is, what is the determinant of the unitary transform matrix? Option A is 0, option B is plus minus 1, magnitude is 1, or option C is infinity, and option D is it depends on the image size. Anyone would like to answer for this question at least? What is a determinant of the unitary transform matrix? Please try to answer for this question at least. What is the determinant of the unitary transform matrix? Then we will see the solution, detailed solution here. Okay, so nobody is interested. So let's see the solution here. So a matrix U is considered a unitary matrix if its conjugate transpose, that is U of X, is also its inverse satisfy this condition if it is a unitary. So U conjugate transpose, that is represented by U of H here. The U of H into U is identity matrix and I is the identity matrix. Already we know that. To find the determinant, then we will apply the property that the determinant of the product is the product of the determinant. So determinant of U of H U is equal to determinant of I if we apply the determinant in both the after equation this one equation. So we can write it like this one. We can just break it. Determinant of U of H into determinant of U is equal to I because determinant of I will equal to 1 only. So I identity matrix we know that, right? That is 1 0 0 1. So determinant of I will be 1 only. That's why here we have taken 1. So since the determinant of the conjugate transpose is the complex conjugate of the determinant, takes 1, the equation will become determinant of u dash determinant of u is equal to 1, and that we can write determinant mod of determinant u square is equal to 1. And again if we take the square root of this one, so determinant of u will be the 1 only, or we can say that here from here determinant of u, so it is a root of 1, so we can write it plus minus 1, right? So with the magnitude 1, so the correct answer is V, plus minus 1 of that magnitude is 1. So option B is the correct answer for this question. Have you understand this question? Is it fine? Have you understand this question? Is it fine to all of you with the solution? Okay. So now moving to our next question. So now next question is calculate the Euclidean distance between feature vectors A is equal to 1, 2 and B is equal to 4, 6. So here two feature vectors are given. Now we need to calculate the Euclidean distance between these 2 points, between A and B. So how we can calculate? Uh, can you tell me at least the formula for Euclidean distance? Is to try to answer. So to calculate the Euclidean distance between the two vectors, if the 2 points are given x1, x2 and x1, y1, x2 and y2. The formula will be root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Yeah, A is correct. That is correct. Yeah. So here, first point A is given and the corresponding coordinate x1 and y1 is 1 and 2. Similarly, for point B is x2 and y2 points are given, that is 4 and 6, right? Now, the formula for Euclidean distance is calculated by, that is d, root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Now put the values of x2, that is 4, and x1 is 1. 4 minus 1 whole square, 6 minus 2 whole square, right? So 3 whole square plus 4 whole square, we will get root of 9 plus 60, that is root of 25, and that is equal to 5. So yeah, option A is the correct answer for this question. Okay, so I hope all of you are getting. This is a basic simple question. Now moving to our next question. The next question is, if a Gabor filter has a very narrow Gaussian window in the time domain, its frequency bandwidth is option A is very narrow, option B is very broad, or option C is 0, or option D is constant. Any answers? Any guesses? If a Gabor filter has a very narrow Gaussian window in the time domain, its frequency bandwidth is. Okay, so let's see the solution here. So the phenomena is this phenomena is governed by the Hinsberg uncertainty principle in the signal processing, which states that the signal cannot be simultaneously localized in both time and a frequency domain. So there is an inverse relation between the time and frequency. So the time duration del t and the frequency bandwidth del f of a Gabor filter are inversely proportional. Okay, so already we know that it also t is equal to 1 by f. They are inversely proportional. And the narrow window effect. So when the Gaussian window in the time domain is made very narrow, it provides high temporal resolution but forces the frequency content to spread out. Okay, so if it is a narrow in the time domain, so it will spread in the frequency domain. So the next one is the Fourier transform property. So mathematically, the Fourier transform of the narrow Gaussian is a broad Gaussian in the frequency domain. So the correct option is very broad. That is option B. Okay. So if a Gabor filter has a very narrow Gaussian window in the time domain, then its frequency bandwidth will be the very broad. Okay. Yeah, correct, Nirad. It's B. Because frequency and time domain signals are inversely proportional. Okay. Now, okay. Moving to our next question. So now our next question is, which transform is famously known for energy compaction? That is concentrating energy into few coefficients, making it ideal for JPEG compression. Option A is DFT, that is a discrete Fourier transform. Option B is KLT, that is Korolov transform, or option C is DCT, that is a discrete cosine transform or Redan transform. So which transform is known as a energy compaction? Say anyone, any idea? Please try to answer for this question. Okay, option B. Someone saying anyone else? Okay, so let's see the solution here. The energy compaction. First one, so the DCT is renowned for its superior energy compaction property, which means it concentrates the majority of the signal's information and that is energy into just few low frequency components. In the JPEG standard, due to this efficiency, the DCT was chosen to as a core mathematical transform for the JPEG compression standard. So it is a computationally efficient also. So unlike some other theoretical transforms, the DCT uses only the real numbers and has fast only the n log n implementation. That is, number of parameters are also less, so that makes the hardware friendly and computationally easy. So it reduces the artifacts also. It minimizes blocking artifacts compared to other transforms like DFT, and DFT has a very long mathematical equations and everything. That's why DFT is very computationally not efficient. So the correct option is DCT, that is discrete cosine transform. Okay, so option C is the correct answer for this question. DCT is known as a energy compaction method that concentrates the energy into a few coefficients. Okay, DFT is not computationally efficient because it is taking both values, real and imaginary, as we have seen that. But in DCT, we are taking only the real values, that is cosine values. That's why. So now moving to our next question. Is it fine? Have you understand this question? Okay, so now moving to our next question. So our next question is for the vector x that is given 3, 4. What is the L2 norm? That is Euclidean length. What will be the L2 norm of a given vector? Anyone? Okay, so that's all. So the L2 norm, also known as a Euclidean norm of a vector, the L2 norm of a vector, that is, let's say x is given as a x1, x2, and xn transpose is calculated by this formula, that is mod of x2, that is the root of summation I is equal to 1 to n xi square. So it is calculated by square root of the sum of the squares of its component. Okay, the L2 norm of a vector is calculated by square root of the sum of the squares of its component. Okay, so here it is given I is equal to 1 to 2 vectors is only given. So x I square. So you can say that if you just open summation x1 square plus x2 square, the root of that is 3 square plus 4 square, so 9 plus 16, so that is root of 25, and it is equal to 5. Okay, so L2 norm of the given vector is 5. So option C is the correct answer for this question. Okay, yeah, option C is the correct answer. Yeah, okay, so now moving to our next question. So our next question is, an image f of x comma y has a spectral support, that is a non-zero Fourier transform value concentrated in a rectangle size Bu and cross Bv aligned with the axis. If the image f of x comma y is rotated especially by angle theta is equal to 45 degree to create gx comma y, which of the following best describes the region of support for the Fourier transform Gu comma v? Option A, a rectangle of side Vu cross Vv that align with the axis. Option B is a rectangle of size root 2 Vu into root 2 Vv aligned with the axis. Or option C is a rectangle with a with of size Bu cross Vv rotated by 45 degree, or a square of side max Vu Vv. Which option can be a correct one? So an image f of x comma y has a spectral support is concentrated in the rectangle of size Bu and Vv that is aligned with the axis, and if the image is rotated by a degree 45 degree to create Gx comma y, which of the following best describes the region of the support for the Fourier transform? Anyone? Any answer? Okay, so let's see the solution here. So the rotation property of the 2D Fourier transform that states that if a spatial image f of x comma y is rotated by an angle theta to produce gx comma y, so its Fourier transform f u v is rotated by the same angle theta in the frequency domain as well. So mathematically that can be represented by g of x y is equal to f of x cos theta plus y sin theta minus x sin theta plus y cos theta. Then the new transform will be the this one Gu comma v Fourier transform, that is in frequency domain, u cos theta plus v sin theta minus u sin theta plus v cos theta. So this initial spectral support of the rectangle defined by the boundaries of the non-zero values in the UV plane, and that dimensions Vu and Vv aligned with the axis. Okay, so since the entire frequency plane is rotated around the origin by a degree 45 degree, the geometric shape of the support remains the rectangle at the same dimension, but the orientation change related to the u and v axis. So the region of support of the Fourier transform GUV is a rectangle of size BU into VV rotated by an angle 45 degree. So option C is the correct answer. A rectangle of size VU and VB rotated by angle 45 degree. Is it fine? Is it fine? Can we move to our next question? Okay, so moving to our next question. Now, next question is consider a discrete signal of f of n that is given as 10, 6, 8, 4, 12, 8, 6, 2. Perform a label 2 Haar wavelet decomposition. The final set of coefficients will consist of one approximation coefficient and three sets of detail coefficient. Okay. What is the value of level 2 detail coefficient? Okay. So what will be the value of the level 2 detail coefficient? So how we can solve this question? So already we have seen that in the Haar wavelet transform, we need to pair with the adjacent element. So here the function is given. So now first we need to take the averages and differences with the adjacent coefficients. So first we need to make a pair, then just calculate the average and distances of the given pairs. Okay. So what are the different pairs here? So Fn is given, that is at 10, 6, 8, 4, 12, 8, 6, 2. What are the different adjacent pair? So first one is 10, 6, right? Second one is 8, 4. Third one is 12, 8. And fourth one is 6, 2. Second, third, and fourth pair. Now we need to find out for the averages and distances differences, that is a label 1 decomposition. We can call it a label 1 decomposition. Label 1 decomposition. Okay. So first we will find out the averages. Okay. So we can say that A1 for this one. So for this pair 10 plus 6 by 2, you will get 16 by 2, that is 8. Similarly, for 8 plus 4 divided by 2, you will get here 12 by 2, that is 6. Then 12 plus 8 divided by 2, that is 20 by 2, is equal to 10, and 6 plus 2 divided by 2, that is 8 by 2. This one is 4, right? So the averages that you have got, this one, A1. So A1 is 8, 6, 10, 4. This is the first level of decomposition. Now we need to find out differences. We can represent it by D1. So similarly, we need to find out 10 minus 6 divided by 2, that is 4 by 2. 2 here you will get. Now 8 minus 4 divided by 2, here you will get 2 again. Yes. 12 minus 8 divided by 2, here again you will get 2. 6 minus 2 divided by 2, you will get 2. So D1 you will get 2, 2, 2, 2. Okay. So this one is a label 1 decomposition. Now let me just add one more slide here. So here, this one is a label 1 decomposition. Now move to a label 2 decomposition. Okay, so whatever value we have got in the level 2, level 1 decomposition, we will take the as a pair, then we will perform averages and differences on the level 1 decomposition results. Okay, so now we need to find what are the different. A1 is our 8, 6, 10 and 4 we have got, and D1 we have got all 2, right? Now make a pair of adjacent values. So first one for the this one 8, 6 and 10, 4. So first we will now find out averages, that is A2. So here 8 plus 6 divided by 2. So here you will get 7, and next one is 10 plus 4 divided by 2 is again 7. The differences is similarly we have to do for this one also, that is D2. So 8 minus 6 divided by 2, that is 1, and 10 minus 4 divided by 2, here it is 3. So here A2 now we have got 7 and 7, and D2 we have got 1 and 3, right? So they have asked for the differences in the label 2, but in the question it is also states that here the final set of coefficients will consist of a 1 approximation coefficient and the 3 sets of detailed coefficient, right? So already 2 sets of the detailed coefficient we have performed. Now for the next one, for the final one, we need to find out the level 3 detailed coefficient. Okay. So now next, or we can say level 3 decomposition here. Okay. So again we need to find here two values we have got. So averages and differences. For averages I am just writing A3. So 7 plus 7 is divided by 2. So here again you will get 7, and for D3 you will get 7 minus 7 divided to 0. Now if you find out for this one also, so you will get some values 2, 2 again, and 0, 0, right? For the differences. So the final value for this one, the minimalist value is 0. So here again, option D is the correct answer only because they are asking for the differences. Detailed coefficient, that is the differences at the second scale. So that value is 0, right? The final approximation only we have need to give only one approximation coefficient. That's why the correct answer is 0. Okay, is it fine to all of you? Is it fine? Can we move to our next question? Anyone, any doubt? Okay, so moving to our next question now. So now our next question is here. Yeah, this is a level 3, but only we need to give the answer only the in the question itself it is given, right? The final set of coefficients will be consist of one approximation coefficient and three sets of detailed coefficient we need to perform. That's why we have gone to level 3, because in the level 2 here, okay, yeah, in the level 2 we are not getting the any values, and we need to answer in only one. In the options only one value is given. That's why we will move to the level 3. Okay. So our next question is, you are given a data set consisting of the three two-dimensional vectors. The three vectors are given x1, x2 and x3. Now we need to calculate a covariance matrix and determine the fraction of the total variance captured by the first principal component. the largest eigenvalues. So whatever the largest eigenvalues, we need to find out the total variance captured by the first principal component. Actually, we need to find out the fraction of the total variance captured by the first principal component, that is also related to the largest eigenvalues. Okay, so how we can calculate this one? Anyone, any idea? Okay, so for that one also, first we need to calculate the mean of the of these given vectors or given features. So first we need to calculate mean of the given vectors. Okay, so three vectors are given, but two components only, x and y. So mu x first, whatever it is in that x. So in the x position, this one, and this one. So mean of these three, 2 plus 3 plus 4 divided by 3. So here you will get 9 by 3. So 3. And mu I similarly we need to calculate 1 plus 2 plus 3, that is divided by 3. So here it is 6 by 3, that is 2. So mean vector that we have got, you can say that mu in both x and mu only. So mu we have got 3 and 2. That mean vector we have got 3 and 2 transpose, you can say that. Now we need to calculate the covariance matrix that is represented by sigma, or here x is also taken. So it is fine overall calculated by 1 by n minus 1 summation x dash and x transpose. So what is here x dash and this one is same. So x dash is x I minus mu x I and y I minus mu y. This is a simple multiplication of these two vectors, that x dash or x is represented by this one. Okay. So first we need to find out these components. Okay. So first we will find out x1 dash here. So x1 here it is I only. So I means two values are there, 1 and 2, 1 and 2, like this one. When regarding three vectors are there. So for the three vectors we need to calculate the x dash. So first one is that 2 and 1. So 2 minus mu x is how much? 3, right? And then 2 minus 3, just a minute. And at the y position, 1 minus mu y is how much? 2, right? So what we have got x1 dash? We have got the values of minus 1 and minus 1 transpose here. You can say that because everything is represented here transpose, so transpose it is here. Now similarly we need to find out x2 for x2 dash also. The x2 value is 3, so 3 minus 3 and again 2 minus 3 transpose. So again you will get 0 and minus 1 transpose. 3 and 2 here. So 3 and 2. So it is not a, it is all whole 0 will be there. Whole 0 vector we have got here. Now similarly, just I need to remove it here to find out the next value. So mean vector is 3 and 2. Here already it is written. Okay. So x3 dash we can calculate by 4 minus 3 and x3 minus 2 transpose, right? So x3 dash will be 1 and 1 transpose we had got. So now we need to find out x dash and x dash transpose for all the three vectors. So first we need to find x1 transpose. So x1 is minus 1 and minus 1 and transpose will be minus 1 minus 1. So overall vector what we will get here 1 1 1 1, right? So just row multiplied by column. So this matrix you will get. Similarly for x2 dash and x2 transpose we will get 0 0 and 0 0. So all 0 matrix we will get here. Now I'm just removing it from here to calculate further. Now next one is x3 dash x3 transpose. So this value is 1 1 and the transpose will be 1 1. So matrix is 1 1 1 1 you will get. Now what is in the formula? That is find out the overall covariance matrix, that is a 1 by n minus 1 summation of x dash x transpose. So here it is I. So you can just write it I. Okay. So sum of all the matrix here n is equal to 3. 3 vectors are there. So summation we will get 3 minus 1 and the summation of all the 3 vectors. So if you add all the 3, these 3, if you add, so you will get overall vector 2 2 2 2 because it is 0. So 1 plus 1 1 plus 1. So you will get 2 2 2 2 vector. Now it is also 1 by 2 2 2 2 2. Overall matrix you will get 1 1 1 and 1. Okay, so this is our covariance matrix. Now from here we need to find out the eigenvalues. Okay, so from the that is also the principal component. So how we can find out? So already we know that to find the eigenvalues, the characteristic equation, that is sigma minus lambda I is equal to 0, right? I'm just removing it from here. So already that all those things we have calculated. So our final matrix is this one, covariance matrix. So 1, 1, 1 and 1 minus lambda 1, 0, 0, 1 is equal to 0. So 1 minus lambda 0, 0, sorry, 1, 1 will be there. 1 and 1, then 1 minus lambda. So overall matrix that we have got. So here after we need to find out the determinant. So 1 minus lambda whole square minus 1 is equal to 0, right? So here we will get is just open the whole square a minus b whole square. So here you will get 1 plus lambda square minus 2 lambda minus 1 is equal to 0, right? If you open a square plus b square minus 2ab, so here minus 1, 1 will be cancelled out. Lambda square minus 2 lambda is equal to 0. If you take lambda as a common, so lambda minus 2 is 0. So what are the two different lambda values? 0 and 2. What is the corresponding maximum? Lambda maximum is 2, right? Is 2. Now we need to find out the fraction because they have sent the fraction of the total variance. So this is a variance. So total variance is this one. So here we can like say that lambda 1 is 0, lambda 2 is 2. So lambda 1 plus lambda 2. So that is total variance is 2. So to calculate the fraction, just I'm removing it from here. The fraction is calculated by lambda 1 divided by lambda 1 plus lambda 2. Okay, so lambda 1 corresponds to a maximum value. So 2 divided by total variance, so overall n. So that means that is a 100%. We can say that it is a overall value is 1, so 100%, right? So the, the fraction of the total variance captured by the first principal component is 100%. So option D is the correct answer for this question. Is it fine, all of you? Have you understand this question? Any problem or any doubt? Anyone? Any doubt? Anything? Okay, so now the questions have been completed. So someone has asked about the inverse Redon transform. Is it there in the class? So already I have added the detailed. Okay, yes, Minad. Here, so basically what inverse radiant Redon transform does. So to understand how to recover a 2D function f of xy from its line integral or the projections using Fourier slice theorem or filter back propagation. So the key is the inverting of the Redon transform, that is the Fourier slice theorem, and also called as a projection slice theorem, that connects the 1D Fourier transform of the projection to 2D Fourier transform of its original image. So the here mathematical or theorem statements is given. So the 1D Fourier transform of the projection, that is Redon transform function ds theta with respect to s, that is equal to the s is the slice of the 2D Fourier transform f of uv of the original image f of x comma y that has been taken at the different angle theta through its origin. So mathematically, can be represented g of w theta via 1D Fourier transform of the given projection g of s theta. So this is a Fourier transform of the g of s theta, and it is represented by this formula g of minus infinity to infinity g of s theta e to the power minus j 2 pi omega s. It is a simple Fourier transform formula is that. So if we let f of uv be a 2D Fourier transform of the given image f of xb. So already we have seen that in the this is a simple Fourier transform of the given time domain signal that is represented by f of uv. So g of omega theta, that is also that theorem states that f of omega cos theta and omega sine theta. And here the interpretation for this one is, if you take a 2D Fourier transform of the object, the values along a line at angle theta that passing through the origin are the exactly 1D Fourier transform of the projection at the same angle. Okay. So if you are taking the 2D Fourier transform of the given object or given point, the value along the line at angle theta will pass through the origin at exactly the 1D transform of the projection at the same angle. We have seen in the one question also on that. So now after this, to recover the f of x comma y using the inverse 2D Fourier transform. So this is also the inverse 2D Fourier transform formula, that is f of x comma y, that is will vary minus infinity to infinity for both the directions u and v. F of uv, that is the Fourier transform of the given f of x comma y signal e to the power j 2 pi ux plus ux. So first step is change the polar coordinate. First we need to change its polar coordinate from the Cartesian to polar coordinates in the form of omega and theta in the frequency. So u corresponds to omega cos theta and v corresponds to omega sin theta. And uv du dv is equal to mod of omega d omega d theta by the Jacobian determinant. And these, if we substitute that into the inverse Fourier transform, this formula, so you will get this equation. Okay. Now, after that, we need to apply a Fourier slice theorem. So this is a Fourier from the theorem, as we have seen in the previous slide, that f of omega cos theta and omega sin theta is equal to g omega theta. Now substitute this into this one in the place of s of x cos theta plus y sin theta, and this equation that represents mathematical foundation for the filter bank projection. Okay, now next, these are the components of the algorithm. So first one is the filtering step, that is also called the inner integral. So the inner terms represent the each terms represent some values in the filtered version, that is represented by this one. Here g of omega theta by this equation is the frequency content of the projection, and omega is the ramp filter, here mod of omega. This is a critical component, that is a high frequency, that is large omega are amplified and the low omega will be attenuated. So here y it is also given here. So after that we have to apply the inverse Fourier transform. So the integral converts the filtered frequency back data back to the spatial domain in the S domain, or in the time domain, you can say that. And then next step is the back projection step, that is a for outer integral. Here two integrals are there. First we need to find out the for the inner integral, then for the outer integral. So for the outer integral, what we are doing? So this is the integral sum of the filtered projection. So at the overall angle. So this one is the outer integral equation. So in this back projection, that is for every point x and y in the image, we need to look up value in the filtered projection Q corresponding to the location at this location as x cos theta plus y sin theta, and then overall at angles. So in the here, this one at x cos theta plus y sin theta. So this is a summary of this algorithm. So to implement the inverse Laurent transform with the filtered back projection. So this is a filtering step, one for the inner integral and another for back projection step, that is for the outer integral. In the inner integral, first what we need to do? First we need to take a projection of the in the time domain to, then we need to compute the frequency domain signal corresponding in the 1 by 1D Fourier, fast Fourier transform, and then we need to multiply by omega, that can be a hanging any window to reduce the noise, and then again compute back into the 1D FFT by using the filter, that is also called the filter projection. Similarly for the projection step also, for every pixel xy sum of the contribution for all the angles. So is it fine? What is your doubt? I want to ask. So yeah, for others, if you don't have any question, any doubt, so you can leave the session. Now the questions have been completed. So if you have any doubt, you can ask. Otherwise, you can leave. So yes, Neela, any problem? What is the question here? Is it fine? I will have to read through it again, but thank you. Okay. So is it fine? Have you understand or not? Just uh, remember the steps for the inner integral as well as for the outer integral. What is the, I mean, process? Okay. Okay, so if you anyone have don't have any doubt, so now we can close the session or you can leave the session also. So thank you everyone. Thank you for joining this session. Okay, I have a doubt. And four. Okay. Uh, in the current one that has been given to you, Anu. Okay, so that already submitted, right? Or not yet? Yeah, yeah, you can unmute yourself and you can ask Anu. Okay, what is your doubt for the assignment 4? Okay. So actually, I didn't see the assignment of the current assignment because we are not able to access. So we can access the previous assignments, not a current one. So what is your doubt? I didn't understand here. So how to find the KL transform? Okay, options are confusion. So have you just gone through the correct process or correct procedure? If no answers are matching and if options are wrong, then you will be assigned uh, positive marks. So that is not a problem if the wrong answer will be given in the options. So is it fine or should I need to check it?